Welcome to Trust the Process. In this video, we'll be discussing about tutorial sheet 2. Okay, so question 1 of tutorial sheet 2 says a 0.250 kg block attached to a light spring oscillates on a frictionless horizontal table. The oscillation amplitude is 0.125 meters and the block moves at 3.00 meters per second as it passes through the equilibrium at x is equal to 0. The first question says, find the spring constant K. So, this tutorial sheet is mainly going to be solved by three equations of the total energy. So, the first equation that we know for finding the mechanical energy is equal to 1 over 2 mv squared plus 1 over 2 kx squared. This equation shows that mechanical energy is going to be given by kinetic energy plus the elastic potential energy. That is for a spring that has been horizontally placed. The other equation for mechanical energy is going to be mechanical energy is equal to 1 over 2 Ka squared. Now, for this one, when the spring has been stretched, let's say to an amount x is equal to a, or it has been compressed to an amount x is equal to negative a. At that point, at the turning point, the velocity is equal to 0. And when x is at its maximum, or the maximum displacement, is what we call the amplitude. So at the maximum displacement or the minimum displacement, the velocity becomes 0, hence x becomes a, and the mechanical energy equals the elastic potential energy. That's why we have this equation. Then the third one, we say mechanical energy is equal to 1 over 2 mv max squared. So this equation is going to be also the total energy of the spring at the equilibrium point. So when x is equal to 0, the block is going to attain its maximum velocity. And as you can see from the first equation, when x is equal to 0 here, the velocity we are saying is going to be maximum. So x being equal to 0, meaning this elastic potential energy becomes 0, and the total energy becomes equal to the maximum kinetic energy. That's how come we have this equation. So, when you are solving this question, according to what we've been given, if we do the data collection, the question is saying that we have a block of mass, so meaning we've been given the mass which is 0.25 kg. Then we've also been given the amplitude. The oscillation amplitude is 0.125 meters. Then we also have the block speed at the position x is equal to 0. So when they say the block speed at x is equal to 0, that simply means that we've been given the maximum velocity. So the maximum velocity happens when x is equal to 0, which is also known as the equilibrium point. So the maximum velocity given is 3.0 meters per second. That is what we have. Now, how do we find the spring constant? The spring constant here can be found by equating any of the two from these equations. So we cannot use equation 1 because we don't know the velocity. This velocity that we have here isn't going to be the same as the maximum velocity. It will be the velocity that is going to be less than the maximum velocity. And then the x that we have here isn't the same as the amplitude. The x has to be less than the amplitude. So we can get equation 2 and equate it to equation 3 because both of these equations are used to find the mechanical energy. So we'll say 1 over 2 Ka squared is equal to 1 over 2 mv max squared. So the question wants us to find the spring constant. Hence we are going to say half goes, then divide both sides by a squared. You are going to say k is equal to mv max squared over a squared. Alright, so now from this expression you can clearly see that the spring constant is given by mass, which has been given, multiplied by the maximum velocity squared, which has also been given. We have the maximum velocity there, and the amplitude. So the spring constant will be equal to 0.25 multiplied by the maximum velocity is 3, which is going to be squared, divided by the amplitude, which is 0.125 squared. And the units for this will be Newton per meter. That is your answer. Alright, let's go to the next question. The next question is saying, calculate the total energy of the block. Calculate the total energy of the block spring system. So how do you calculate the total energy of the block spring system? So in order for us to calculate the total energy, you can use any of the three equations again. So what is it that we know now? So we have an additional information. We can add another information on the data that we have. The information that we can add is the spring constant, because we've already found the spring constant. So finding the total energy of the block spring system, you can use either equation 2 or equation 3. But I would advise you to use equation 3, because equation 3 has all the quantities that has been given to us. So using equation 3 to find the total energy, we are saying that the total energy is equal to 1 over 2 mv max squared, of which we know that the mass has been given to be 0.25, and then the Vmax is also known to be 3, which is going to be squared, and the units there will be joules. That is going to be our total energy. Then the last question is saying, find the block speed when x is equal to a over 2. Find the block speed when x is equal to a over 2. So how do you find the block speed when x is equal to a over 2? You can use this equation, equation 1, and combine it with any of the two equations. So we can combine it with equation 2. We'll say the block speed when x is equal to a over 2, getting equation 2, which is 1 over 2 ka squared, and equating it to equation 1, which is 1 over 2 mv squared plus 1 over 2 kx squared. So we know the spring constant, we know the amplitude. We've also been given the mass of the block. We are looking for this speed. We know this spring constant, and we know the value of x. The value of x here, according to the question, they are saying x is equal to a over 2. That is our x. So we just have to make this one subject to the formula, and that can be done by saying this one goes the other side, meaning you have mv squared is equal to ka squared. Then we have minus kx squared. So v squared will be equal to, when you factorize k there, you're going to have k, open brackets, a squared minus x squared, then divided by m. So our v is going to be plus or minus the square root of k over m, then a squared minus x squared. That is what we are going to have. So clearly you can see that we have the value of k from the first question. You found the value of k. You also have the value for the amplitude, which is 0.125, and the value for x is a over 2, meaning you get the amplitude, which is 0.125, then you divide it by 2. That is going to be the value of x, and the mass has also been given. So the value for the velocity can either be positive or negative depending on your take. So if you consider the block going to the right, then you are going to use a positive value. If the block is going to the left, then you are going to consider a negative value. Yeah, so this is question 1 of tutorial sheet 3, and it ends here. Thank you.